So accommodation is the process of the eye changing the shape of the lens to be able to focus on things that are far away and things that are close. Now, of course, sometimes people have disorders of that, and that's why they need to wear glasses. The two most common ones are far-sighted and nearsighted, otherwise known as short-sighted. So let's talk through these. So firstly, somebody who's short-sighted or nearsighted. Somebody who's short-sighted or nearsighted, they can see things up close well, but they can't see things in the distance well. So up close is good, is in focus. Distant is where they have their problems. It's out of focus. So people who are short-sighted, they need to wear corrective lenses to see things in the distance. Okay, so I'm going to show you what the disorder is and I'm going to show you how we correct it. Alright, when we're looking at things that are a long way away, we say that the light rays are coming to the eye parallel. Light rays are parallel. Short-sightedness is generally a problem that younger people have, and it's because their lens is too thick. Lens is too thick. So the light rays are coming in parallel. They don't need to be bent very much to focus on the retina. Because the lens is too thick, what happens is that the light gets bent too much by the lens, and so the focal point is behind the retina. So let's see how we can correct short or nearsightedness. So the light rays are coming in parallel and the lens is too thick. So the only thing that we can do is put a corrective lens in front. So what we want to try and do is bring the light rays out, diverge the light rays so they come in on a sharper angle. So I'm going to put a concave lens here to make the light rays diverge. So the light rays come in on a sharper angle. Then they bend with the thick lens so that the focal length, the focal point, is on the retina. So the correction is with a concave lens, because that concave lens diverges the light for when it hits the lens. Let's see what happens with long-sighted. Somebody who's long-sighted can see well in the distance but has trouble seeing things that are up close. And the reason for that is that the light coming from a close object, we say that the light rays come in at more of a sharp angle. This is often a problem of older people, and it's because the lens is less flexible, and it's because the lens is too thin. So the way the lens accommodates is it's got a natural resting thick position and it becomes thin by muscles pulling it and stretching it like that. Older people have lost the flexibility in their lens, so it's constantly in a more of a thinner position. It doesn't have that same power as it did when they were younger. Alright, so looking at things that are up close, the light rays are diverging as they hit the lens. Now, the lens doesn't have enough power to be able to refract the light enough to focus on the retina, so in this case, the focal point is behind the retina. The focus is behind the retina. So, you can see what needs to happen here is that we need to add a lens to bend the light more before it gets to the lens of the eye. Because we can't change the thin lens of the eye, it's as good as it's going to get. And the light rays, of course, are diverging like this. So what we can do is we can put a convex lens in front of the eye, and that's going to allow the light to start to bend. I might change colour to be able to, so it's going to bring the light in like this when it gets to the lens, so that it's now in a position for the lens to be able to focus it on the retina. So the treatment or the correction is a convex lens. So somebody who's short-sighted, that's corrected with a concave lens, and somebody who's long-sighted, that's corrected with a convex lens.